So following on from the previous video, I said I would give you some examples of a piecewise function. So here, take this example here. When x is strictly less than -2, it would be 3. So this here would be what so when x is less than when x is strictly less than -2, so that's in this domain here. It would be 3. So your graph will look something like this. 3 is here. So and remember, it's strictly less than 2, so it has to be an empty circle here. Okay, so that would look like this. And when, well, for this region here, in this domain here, it will follow this rule here, y equals x squared. Well, y equals x squared is like this. 0 here, 1 is 1. So when it's -2 squared would be 4. So it's when it's +2, it will be 4. So it will be a quadratic like this, something like this. But remember, it's only valid within this range here. So it's valid within when x is equal to -2. So equal to means it includes this bit here. Okay, and then equals to 1 here, so it includes the 1 itself, so it will be a black circle like this. Okay, so that means so you got to delete the rest here, because the rest is in a different domain. You see, the rest is in this domain here, in this domain here. So we have to follow this rule now. When x is greater than 1, we have to follow this rule here. So you drawing a line of y equals 3 minus x. That means the intercept is 3 has a gradient of -1. So intercept of 3, gradient of -1. So it's going to be something like this. Okay, but it's strictly greater than 1. So it cannot be because it's strictly greater than, it has to be an empty circle. So remember, all this here is not valid because it's out of the range. You see, the range is x being greater than 1, strictly greater than 1. So you have to delete all this here. Hang on. So it would be like this. Okay. Yeah, because it's strictly greater than, so it has to be a white circle here. And it cannot be a black circle here, because otherwise there exists a vertical line where you have two values for, well, it has to be a white circle here. Okay, so this here now is a function. You see, so your piecewise function would look like this. Okay, so here's another example. Hang on. So for this one here, when x is well, just draw a graph of y equals -2. So y equals -2 will be something like this. Hang on, it would be something like this. But it's only valid for when x is less than or equal to -1. Well, -1 is here, so it's only valid from here. Well, I've got to get rid of the rest here. Hang on. So it looks like that. Now in this range here, strictly greater than 1 and strictly less than 2. Well, let's just draw this line first. Y equals x plus 1. So that'd be a straight it would be a straight line with an intercept of 1, which is here, and then well, gradient of 1 as well. The gradient of 1 will look something like this. Okay. But then it's only valid when x is strictly greater than 1 here. Greater than, sorry, this should be a -1. Sorry. So this one here is it would be like this. Hang on. It would be an empty circle here. So hang on. Let me erase this. So it will look something like this. An empty circle here. Okay. And then it has to be strictly less than 2. So 2's here, strictly less than, so it has to be this. So let me erase this. Okay, and then for x to be equal to be greater or equal to 2. So I will have to follow this here. I'm just going to visualize this inside my head as y equals 4 minus x. So it's like me drawing a straight line. Y equals 4 minus x. So the intercept is 4 here, minus x. So it has a gradient of 1. Sorry, it has a gradient of negative 1. So it will be like this. Okay, but it's only valid for when x is equal to or greater than 2. So 2 is here. So it's, well, it includes 2 itself. So it has to be a black circle here. Let me erase this here. So this here. So your function here, the graph of this function here would look like this. This line here, and this line here. Okay.